Welcome to lesson 4, which is SPSS, Student Problem Solving Session. So I'm going to get a scenario and show you what to do. This lesson intends to remind you about the importance of layout in your work. The layout is what will earn you good mark. Remember, we said number 1, sort out the quantities and their units. Then number 2, write down the knowledge, which may be in form of a correct formula. Number 3, correct substitution. You have to remove the letters in the formula and put in the figures that you are given in the correct units. Then number 4, you have to write the final answer with the correct units. So we are going to see each step using the example above. So let us focus on the entire question, and we see a force of 7.5 Newton stretches a certain spring by 5 centimeters. Okay? How much work is done in stretching the same spring by 8 centimeters? Okay? So let us first sort out. So we are doing sort out quantities, and units. So we have two scenarios here. There is a first scenario where you are given F is equal to 7.5, correct? Yeah. F is equal to 7.5 Newton, and then we are told it stretches by 5 centimeters. Then we have another scenario. We have F is equal to, we don't know, and then we have the extension is equal to 8 centimeters, and we are asked what is work done. Okay, so from the first scenario we can see the knowledge required here. Knowledge required here is F is equal to KE, and therefore K is equal to F over E. See? In other words, there are situations where you have to analyze, synthesize the information, okay? Try to sieve. And then you come up with bits. Kapisi kamoja, tena kapisi kingine. It may require that. Now, from the sorting out of quantities, extension is in centimeter. I would like you quickly to note that this is the same as when you divide it by 100. So you get 0.05 meters. Therefore, when I come to substitution, you remove the letters and put the formula, the numbers. So I have like K is equal to force. My force is 7.5, and then you divide it by 0.05, you get, I think, 150 Newton per meter. Now let me just adjust a bit the camera so that we are together. Just a bit the camera there. So far, okay. So I know my spring constant is 150 Newton per meter. Okay, that is my spring constant. I'm asked to calculate work, but I don't know the force that caused the extension of 8 centimeters. I can use this work now, this constant here. Okay, I can use it there. I can say but force is equal to KE. Okay, then I take 150, I multiply by extension, which has to be 0.08 there, which gives me what now? Quickly, those who have calculators, you can do it. I can do it using my phone. That gives me like 12 Newton. Think 12 Newton. Okay, so my final knowledge is work is equal to a half FE. Another student will say work is equal to a half KE squared. So work is equal to a half FE. Just note one thing, I didn't use 7.5. Why? 7.5 was force responsible for an extension of 5 centimeters. It was not force responsible for 8 centimeters. So you can see there is a bit of work that you do. Okay? So having reached this place, I can choose either to use this or that. For the purposes of learning, I will use either and we see if we'll get the same answer. Okay? So I want to lower my camera further down before I bring it up to conclude. So let me lower it down there. Okay? So we have alternative 1. Alternative 1 is work is equal to a half by F by E. Then substitute a half by force 12, extension 8. Okay? So what do we get now here? We can say, whichever way you want, this cancel that to give me 4. So what do I get here? I get 48 joules. Is that correct? Yes, I get 48 joules. What about alternative 2? Let us see. Alternative 2. Alternative 2 will give me work is equal to a half by K by E squared. So what do I get? A half by K 150 by 0.08 squared. Again, we can do it in another version. A half by 150 by 8 over 100 by 8 over 100. Those who do not have calculator, we can have that. We focus there. We can have a half by 150 by that. So what does it give us again here? Let us see now. Let us see now. Here it is. This is a mistake here. This is 0.08, which is 0.04, which is 0.48 joules. Sorry for that. Let us come here. Again, we can cancel this to go with that is 4. Okay. So we just do something here. This is 1 0 cancels there. Okay. So we are remaining with 15 times 32. So we do 15 times 32. This and this is 15. This and that 4. this and that 10, this and that 2, and then plus 1, 3. So 0, 8, 4, and then how many decimal places? 1, 2, 3. So 1, 2, 3. So we are getting 0.48 joules. So let us get that right, folks. From here, right here, we have work is equal to half Fe, and work is equal to half Ke squared. Okay, so again I focus a bit the camera. I hope it is seen from there. Work is equal to half Kfe, and here work is equal to half Ke squared. So the most important thing for you to note is that we had a force of 7.5 causing an extension of, we had a force of 7.5 causing extension of 5. We are asked to calculate work. We are asked to calculate work when the spring extends by 8. We don't know the force that caused extension of 8 centimeters. So let us get the core of the question, okay? The 7.5 caused this extension. We do not know the force that caused 0.08. So how do we go about it? We know the knowledge is F is equal to Ke. You can write stroke. You can say even work is equal to a half Fe. That is where he wants you to get to. You must know what are the quantities I can calculate from the given information, okay? Which quantities can I calculate from the given information? So I have F and I have E, I can get K. That is the spring constant. Now, you come down here, you get K is 7.5 Newton divided by 0.05. So my spring constant is 150 Newton per meter. Having known that, we check. Having known that, we check now. We check this work. Force is equal to K times E. I know already K, I multiply by extension in the correct units. So I'm working with the SI unit. So you have 150 times 0.08, or you can say 1.5 times 8. 1.5 times 8. 1 times 8 is 8. Half of 8 is 4. So you have 8 plus 4 gives you 12. Okay? So I now know the force that caused this extension. And I'm supposed to get the work done with this scenario and not this. This was to propel you to get to this second stage. So having gotten the force responsible for extension of 0.08, I can now use any of these two, as I have shown the two of them down here. I've shown the two down here, right there. Sorry, let me again, my camera is, my camera is, I think there you will be able to see everything. You have alternative 1, where I'm using work is a half Fe. Then you get the answer, 0.48. Don't make a mistake like what I did, I wrote 8. I decided to work with SI, so it is that. Alternative 2, I'm using a half Ke squared. You substitute, compute, final answer. So you have good stuff here where you will score marks. Okay? So, folks, that is simple example, but you need to know. We will work another example until you get the different scenarios that can be asked. So do not just think you will be given distance and you just cram distance. No, you have to interpret scenarios correctly and know the 4 procedures. 1, sort out. Sort out. Write a letter standing for the quantity given and its units. Okay? So sort out quantities and units. 2, write the correct knowledge. Write the correct knowledge. Questions that deal with the calculation are handled using specific formulae. Okay? 3, substitute. Remove letters and put in the correct units. Those are figures. Figures which are correct. 4, write the final answer. Write the final answer with correct units. 1, do you remember? 1, yes, sort out quantities and units. 2, write the knowledge, which in most cases is a specific formula. 3, substitute correctly. As you substitute, you can carry out computation. Substitute and computation. And then 4, the final answer with the correct units. Bye bye folks. Keep on subscribing. Bye bye.